Hello everyone, I am Han Xue from Shanghai Jiao Tong University. Today I'm excited to share our work entitled Freestyle Layout-to-Image Synthesis. First, I would like to give you a short 1-minute overview. In this work, we introduce a new task called Freestyle Layout-to-Image Synthesis, which aims at generating unseen semantics onto a given layout. To this end, we propose a powerful model called FreestyleNet. It leverages a pre-trained text-to-image diffusion model and applies a novel rectified cross-attention to integrate layout. FreestyleNet manages to put a wide variety of semantics described by the text prompts onto the given layout. Its high freestyle generation ability can be demonstrated from these examples, including binding novel attributes, generating novel objects, and rendering the image with novel styles. Now let's dive into details, starting with the background and motivation of our work. Layout-to-image synthesis aims to translate a layout into a realistic image. Here we focus on one type of layout, which is semantic mask. Most existing LRS models can only generate images for a closed set of semantic classes. For example, these objects are from the Cocoa Stuff dataset. However, one may want to synthesize a wider range of semantics without retraining the model on new datasets. To enable this freestyle capability, we introduce a new task called Freestyle Layout-to-Image Synthesis. As shown here, novel attributes, styles, and objects can be faithfully generated onto the given layout in the context of FLRS. This new task brings us two benefits. First, the freestyle property breaks the in-distribution limit of LRS, enabling more flexible control over the synthesized images. Second, it has a high potential to enlarge the applicability of LRS results to out-of-distribution domains such as data augmentation in open-set or long-tailed semantic segmentation tasks. To perform FLS, we propose a framework named FreestyleNet. When designing this framework, the first question we encounter is how to generate unseen semantics. As we know, large-scale pre-trained language vision models, for example CLIP, have shown the ability to facilitate some discriminative methods trained with limited base classes to predict unseen ones. Inspired by this, we opted to leverage large-scale pre-trained text-to-image diffusion models, the well-known Stable Diffusion in this work, to achieve the generation of unseen semantics. This raises the second question, how to enable the diffusion model to synthesize images from a specific layout. Our solution is to insert rectified cross-attention into Stable Diffusion to integrate layout. This is an overview of FreestyleNet. A text encoder of CLIP extracts the text embeddings from the input text and then injects them into the diffusion model. Starting from a noise xt, the reverse diffusion is performed using a denoising U-net for t time steps to generate the final result x0. The proposed RCA is plugged in each cross-attention layer of the U-net. So I will elaborate on RCA in the following slides. Let's first revisit cross-attention in Stable Diffusion. As shown here, when taking a cute cat as input, Stable Diffusion produces a lovely cat. If we visualize the cross-attention map associated with the word cat, it is obvious that the spatial layout of this cat in the generated image highly resembles the cross-attention map. It means that we can decide an object's spatial layout by modifying its corresponding cross-attention map. Our RCA fully capitalized on this observation, and here's the workflow of it. Similar to the general cross-attention, RCA first obtains image queries, Q, text case key, and text values V through projection layers, and calculates the attention score maps M. Then, the layout is utilized to rectify M to force each text token to affect only pixels in the region specified by the layout. At last, we apply softmax to the rectified attention maps and takes a weighted sum on V to get the output of RCA. By doing so, the semantics from the text are injected to corresponding region in a given layout. Note that RCA does not introduce any additional parameters into the pre-trained model, so we could easily fine-tune the pre-trained model on any set of layout-based training data. The objective for fine-tuning is the same denoising loss used for pre-training. Now let's see some experimental results. First, we showcase some FLS results generated by FreestyleNet. It can bind new attributes to a specific object. For instance, we can specify the car as Porsche or Bugatti Veyron. We can also render the image with the desired styles. An impressive case can be seen in the image on the top left, where we put all stuff in Minecraft. FreestyleNet allows us to directly generate on-scene objects as well, provided that the spatial layout is reasonable. We also compare FreestyleNet to some LIS baselines under the in-distribution setting, since generating on-scene schematics is beyond the reach of prior works. From the visual comparison, we can see that FreestyleNet consistently produces sharper images with fine details. Quantitative comparison results are provided in this slide. Our method achieves a new state-of-the-art in terms of image quality metric FID. PT also adopts a pre-trained text-to-image model, thus obtaining superior image quality, but it implicitly learns to map the input layouts into the space of a pre-trained text encoder, resulting in inferior spatial alignment with input layouts, which is reflected in the MIOU metric. Thanks to the proposed RCA, FreestyleNet has better spatial alignment. So here comes the conclusion. We introduce a new task called Freestyle Layout-to-Image Synthesis, which aims to generate on-scene schematics described by text onto a given layout. To achieve FLS, we propose FreestyleNet that applies rectified cross-attention to the pre-trained Stable Diffusion. Stable Diffusion provides us a vast number of schematics, and RCA allows us to put these schematics onto the given layout. We demonstrate a bunch of applications by translating a single layout into high-fidelity images with a variety of novel schematics using our FreestyleNet. Thanks for your attention. You can scan this QR code to visit our project page for more details.